Hello and welcome to another exam paper walkthrough. Today I'm looking at a half paper and I'm looking at the Edexcel higher half papers. I'm going to be today we're going to be doing a practice set 1B, so that's a half paper 1B, and we're going to be looking at paper 2, so this is a calculator paper. Attached to the description to this video is a link to a Google Drive where you can download a copy of this paper. I would strongly recommend that you have a copy of this either done beforehand or do it alongside the video. I'd also recommend a bit of music on in the background. I've certainly got some going on via earpod. Please, if you find this useful, subscribe if you like. Okay, question 1. Eric travels from the UK to India every year. In 2010, the exchange rate was £1 is equal to 67.1 rupees. In 2012, the exchange rate was £1 is equal to 82.5 rupees. In 2010, Eric changed £600 into rupees. How many pounds did Eric change in rupees in 2012 to get the same number of rupees as he did in 2010? Okay, so for this, first of all, I need to look at the number of rupees that you would have got in 2010. So to do that, I'm going to do 600 multiplied by the exchange rate of 67.1, and then I'm going to have to divide my answer. So that will give me the number of rupees, and then I'm going to have to divide that by the new exchange rate in 2012 divided by 82.5, and that's going to give me the amount it would cost to get the same amount in 2012. So I'm going to type it in just like that. So fraction 600 times by 67.1, divide that by 82.5. Double check my figures, they all look correct. So 488 pounds. Okay, there we go, 488. And question 2, the scatter graph shows some information about 10 cars. It shows the time in seconds it takes each car to go from 0 to 60 miles per hour. For each car, it also shows the maximum speed in miles per hour. So we've got maximum speed and we've got time in seconds. What type of correlation does this scatter graph show? If I drew a line of best fit, which I'm sure I'll need to shortly, it's going to have a negative gradient, so it shows a negative correlation. And the time a car takes to go from 0 to 60 is 11 seconds. Estimate the maximum speed for this car. So this will tend to be a 2-mark question. There we go, 2 marks. And it will be 1 mark for a line of best fit, arguably. So I'm going to place my line and I'm looking for something that will relatively nicely represent the data. So I'm going to go for, I'm going to go there. So my line of best fit, we'll just take that off and just check that we're happy with that. And I think that's okay. And then at 11 seconds, I'm going to go up to my line, and then spin it around to. So where it hits the graph, I want to follow it back to my y-axis and then read off that value. So get rid of my ruler now. So we're looking at this is going up in ones, so I'm looking at about 121. Question 3, solve. So we're looking at simultaneous equations. Quite a nice pair at first look. So I'm going to call this equation 1 and this equation 2. The trick with solving simultaneous equations is that x or our y coefficient to have the same true value. In here we've got true value, the same value. So here we've got a 1x and a 1x. We've got 2 positives, so we're going to have to subtract 1 from the other. And to keep my y's positive, I'm going to do equation 1 minus equation 2. So 1x minus x would be 0, and then 2y minus negative y would be 3y, and that's going to be equal to 3 minus 6, so that would be minus 3. Divide both sides by 3, y would be equal to minus 1. Okay, my next job is to substitute that value for y into one of my equations. I'm going to substitute it into y into equation 2. There we go. So that's going to give me x minus negative 1 becomes plus 1 is equal to 6. Minus 1 from both sides, we get x is equal to 5. Okay, and I will always tend to do a quick check with whichever equation I didn't use for the substitution, so check that it works. So x is 2 lots 3, and it should be equal to 3. So we know that we are correct. So x is 5 and y is minus 1. There we go. Okay, question 4. Colin, David and Emma, I'm going to call them C, D and E. So normally I'd say read it 3 times. I'm going to extract the information out of it there, C, D and E. So Colin gets 2 monies, so 3 over 10. Meaning that the other 2 get a combined share of 7 over 10. And then Emma and David, so we've got our names the opposite way around. Share the rest of the money in the ratio 3 to 2. 3 to 2. And I've said that I've got them the opposite way around, but I've not written them. So Emma's share was 3, David's share was 2. So that's going to be 2 over 5, that's going to be 3 over 5, because there are 5 parts. So what is David's share of the money? David was 2/5 of 7/10. So 2 over 5 divided by 7 over 10. Right, I'm going to cancel by a factor of 2. 5 and 1, so it's going to be 7 over 25. And I would leave my answer at 7 over 25. Doesn't say in its simplest form or in what form to leave it. So we could give it as a percentage, that's going to be 28%. Or to be fair, we could have, if we hadn't cancelled, we could have arguably left it as 14 over 25, 14 over 50. But that's the answer that I would go for. Okay, question 5. This diagram shows triangle ABC. Work out the size of angle A. So we're trying to work out that angle there. Giving your answer correct to 1 decimal place. So we're looking at a non-right angle triangle where we've got 3 sides and 1 angle. So we're using the cosine rule, and we're actually working at the angle. So cos of A is going to be equal to 2.7 squared minus 1.8 squared. Sorry, plus 1.8 squared minus 3.6 squared divided by 2 lots of 1.8, sorry, 2.7, well, that doesn't particularly matter, times by 1.8. So I'm going to go straight for the inverse, so cos to the minus 1 of that value. So let's do it before we do the cos. So 2.7 squared plus 1.8 squared minus 3.6 squared, all divided by 2 times by 2.7, sorry, times by 1.8. So that should be minus a quarter. And I've miswritten slightly, so it's the cos of minus 1 over 4. So that's going to be bigger than 90. So shift cos answer, it's going to be 104.4775 dot dot dot. So to 1 decimal place, that's going to be 104.5. Okay, work out the area of the triangle, giving your answer correct to one decimal place. So formula for the area of a triangle, area of a non-right angle triangle is a half AB sine C. So we're going to kind of, arguably, I probably should have written this slightly differently. I only ever use this version, but by the labeling of the triangle, that's better. That would hold more true. So I'm going to do a half of 2.7 times by 1.8 times by sine of the angle, and we've got the angle still in our calculators, so it's going to be 0.5 times by 22.7, sorry, not 27, 2.7 times by 1.8 times by sine of the angle. So that's going to give me 2.352837 ... and then round it to one decimal place, that's going to be 2.4. Okay, the average fuel consumption C of a car in kilometers per litre is given by the formula C is equal to D over F, where D is the distance travelled in kilometers and F is the fuel used in litres. D is 190 correct to three significant figures. F is 25.7 correct to one decimal place. By considering bounds, work out the value of C to a suitable degree of accuracy. You must show all your working and give a reason for your final answer. Okay, so to do this, I'm going to first of all look at the bounds of the two numbers before I fully go into this. So if I go D, D has got to be greater than or equal to, if there's three significant figures, it's going to be 189.5, and the smallest, the largest it could be would be 190.5. And then if we do the same for F, so the smallest that F could be would be 25.65, and the largest it could be would be 25.75. Right, so I'm going to work out the largest it could be and the smallest it could be, and then I'm going to look at what they round to. And looking at what they round to will give me my suitable degree of accuracy. So it's going to be whichever number they both round to. So if I look at my C minimum, so my minimum C value is going to be found by taking my maximum D value and dividing it, sorry, I've got that the wrong way around, is going to be found by my minimum C value, D value, and dividing it by my maximum F value. So I'm going to be doing, and make sure I've got these the right way around. Let me just undo that. Right. So my minimum D value was 189.5 and my maximum F value is 25.75. And then I'll do the same for my C max is going to be equal to my D max divided by my F minimum. So that's going to be 190.5 divided by 25.65. Right, so I'll go to my calculator now. So first, my minimum value, 189.5 divided by 25.75. My 5 off. Okay, so my minimum value is 7.35922 ... And then my maximum value for C is going to be 190.5 divided by 25.65. So that's going to be 7.4269. Right, so both numbers would round to 7. Both values would round to 7.4, but then the minimum value to 2 decimal places would be 7.36, and my maximum value would be 7.43. So they split at that point. So I'm going to go 7.4 as both numbers round to this. Okay, and that's how I would do that. That's quite a nice bounds question. So there we go. Right, question 7. Right, let me zoom out slightly. Okay, so we've got a functions question. So f is the function f of x is equal to 2x plus 5. Find the f of 3. So we're placing 3 into that equation. So 2 times by 3 plus 5 is going to be equal to 6 plus 5. It's going to be 11. Okay, our next one, express the inverse function in the form f to the minus 1 in the form f to the minus 1 of x is equal to. So the most straightforward way of kind of viewing this is what we're going to do is put it in as an equation like that and rearrange it to make x the subject. So I'm going to minus 5 from both sides and divide by 2. So y minus 5 divided by 2 is equal to x. So that means that the inverse function, and then I switch them back over. So it's going to be x minus 5 divided by 2. And that's the most straightforward way of viewing it. Or, I mean, you can view it with a function machine if you wanted to. So if I wanted to go backwards from this as a starting point, I would need to minus 5 from both sides and divide both sides by 2. But that's the nicest way of viewing it. Right, g is the function g of x is equal to x squared minus 25. Find g of minus 3. So we've actually got a difference of 2 squares here. I'm not sure if that's helpful at this point. But that's going to be equal to minus 3 squared minus 25. So that's going to be 9 minus 25, which is going to give me 6 minus 16. Find g of f of x. Give your answer as simply as possible. Right. I might use the fact that we've got a difference of 2 squares here. Yeah, I'm going to use the fact that it's a difference of 2 squares. I'm not saying this is the only way of doing it. Right, so if I put the... Right, let's just say that that is x plus 5 times by x minus 5. And then what I'm going to be doing is I'm going to be substituting in 2x plus 5 in replace for x. So g of f of x is going to be equal to 2x plus 5 times by 2x plus 5 minus 5. So that's going to give me, those will cancel, so it's just going to be 2x times by 2x plus 10. And I'm going to slightly simplify that. I can take out a further 2 out. So I can say that it's going to be 4 lots of 4x times by x plus 5. And I think that's probably the simplest format for that. Yeah, we could multiply it out, but I think that's simpler than saying that it would be 4x squared plus 20x. So I'm going to leave it like that. Okay, and then the final part, solve. It is the same thing, isn't it? It is, yeah. So solve, that being equal to x. So 0 is equal to, not bracket. So if 0 is equal to 4x times by x plus 5, it means that x is either equal to 0 or x is equal to minus 5, making both parts of those 0. So x is equal to 0 or x is equal to minus 5. Okay, and question 8. Phil has 20 sweets in a bag. 5 of the sweets are orange, 7 of the sweets are red, and 8 of the sweets are yellow. Phil takes at random 2 sweets from the bag. Find the probability that the sweets will not be the same colour. There are kind of 3 methods that we could do this. We could work at the probability that he takes a red. We can work out the probability that he takes an orange and a red, an orange and a yellow, and a red and an orange and a red and a yellow, or a yellow and an orange and a yellow and a red, and add them all together. We could do 1 minus the probability that he takes 2 orange plus 2 red plus 2 yellow. Or alternatively, and I quite like this method, if I look at the probability that he takes an orange first of all, it's going to be 5 out of 20. And then the probability of him not taking an orange the next time would be 15 out of 19. And I'm going to add on the probability that he takes a red first of all, which would be 7 out of 20, times by the probability that he takes not a red one, which would be 13 out of 19, plus the probability that he takes a yellow first, times by the probability that he doesn't take an orange, which would be 12 out of 19. And that's the way I'm going to treat this. To be fair, they're all going to be over the same denominator, 20 times by 19. So all I'm going to do is 5 times by 15 plus 7 times by 13 plus 8 times by 12. And that's all going to be over the same denominator of 100 and, not 190, 380. So it's going to be 262 over, what did I just say, 380. And then my calculator will cancel that down for me. So if I put my answer over 380, let's just 19 times by 20. And that cancels down to 131 over 190. So there we go. 131 over 190. Could go decimal, but I would leave it as a fraction. Okay, and question 9. P is inversely proportional to the square of x, given that x is equal to 5 and p is equal to 6. Find the value of p when x is equal to 8. Giving your answer correct to 2 decimal places. So I'm going to do this one slightly differently today. Let's just check my values. No, I'm not. So I'm going to say that p is inversely proportional to the square of x. So that means that p is equal to k over x squared. So p times by x squared is going to be equal to k. So that's going to be 6 times by 25. 6 times by 25 is 150. So k is equal to 150. So that's my that's my general formula. So now I found k, I can write my actual formula. P is equal to 150 divided by x squared, and we want to find, so p is going to be equal to 150 divided by x squared, so divided by 64. And it asks for it as a decimal to 2 correct 2 decimal places, so it's asking for a decimal. So, and I've typed that in wrong. There we go. So we're looking at 2.34375, which to 2 decimal places is going to be 2.34. Okay, before I sign out, I'm going to just show you this table. This is quite a useful table. And also the chapter headings tell you which topic they are. But each question is related to these 9 topics. So, for example, if you found question 7 the most complicated, that's functions. That's where you want to target your revision as you move forward. Just slightly interestingly, out of the cohort that sat this in previous years, so there's kind of the reference as to when these which questions these were originally from what paper. The hardest question by all students was question 9. The average mark for that was 20% of the 3 marks. So that gives you a kind of a rough idea how students found that, which is quite useful. Right. I hope you found that useful. Thank you very much for your time in listening. Please, if you've got any questions, comments or feedback, type it into the chat to this video and I'll get back to you fairly quickly. I'm pretty good at getting back. And if you found this useful, please subscribe if you like.